A couple of days ago, I think it's been a week now, I made a poll on my channel asking people what they want the next video to be. And the most popular response was how to independently study mathematics, read through a textbook, take notes, do all that good stuff. And I had filmed the video and I recorded it, I uploaded it to YouTube, but for some reason it was having trouble uploading, and I thought it was uploaded, and I checked and saw that the uploading had been aborted, whatever that means. Basically what it means is that it didn't get uploaded. And I'm kind of glad it didn't get uploaded because I wasn't really happy with how the video turned out, but it had been like a week since I recorded it, and so here we are. So I thought I would talk about a little bit of it right now. So I'm going to try and give you a very brief story as to how I started out being not able to read any math books at all to where I'm at right now. And this basically is when I was in high school, I didn't have to read any textbooks for mathematics. I was completely dependent upon the instructor to tell us how to do something. And just the language of mathematics was very foreign to me. Like if you showed me an example and the concept and principle of what we were doing in class, I could pick it up pretty quickly. I was pretty quick with math. But if I read it in a textbook, I would get really easily confused. For example, if a calculus book said that the derivative of a sum is equal to the sum of derivatives, that would confuse me. But if I saw it on a marker board, then it'd make complete sense. And that just kind of goes with the lack of maturity when you study mathematics, because that's like me at, 16, 17 years old. Anyway, so I basically depended upon my instructor 100% of the time to teach me how to do stuff, and I could do it. And that worked all the way through Calculus 1, 2, and 3, ordinary differential equations. And then when I got to math proofs, it didn't really work out as well, because math proofs is not computational. It's, you have to think philosophically in a way. It requires a different type of reasoning, more or less. And so because I struggled with math proofs so much, I ended up switching from math to environmental science. The reason I chose environmental science was mostly because of my dad's suggestion. I was trying to figure out what to major in, and he thought I would like it. And I did like it, but my heart was more with mathematics. And between graduating with my bachelor's in EES, I decided I wanted to go back into math, and the first class I took after a while was Advanced Linear Algebra. And the book we used was Linear Algebra Done Right by Sheldon Axler. Now, the instructor was very good. I liked the way he did the class. And he was just an overall like normal professor, I would say. His book choice was very good. I really like this Sheldon Axler book. If you want to learn linear algebra, I would use Axler's book. But for me at the time, I think I was like, the year was 2018, so I would have been like 23, I think, at the time. How old am I? Yeah, I think I would have been like 23. So I took the class, but I would be lost in class, and I would have to read through the book. And I would just, when you get into graduate school and you want to take these graduate level courses, master's or PhD, you pretty much have to read. You can't really rely on the instructor too much because there's too much information and he can't get through all of it. So I read through the book a few times, just try to keep up with him wherever he was in class, and then write it down on a legal pad just to make sure at least I had seen it once before. I would definitely do that if I was preparing for a test. And then when I went into graduate school, the master's program, I took modern algebra and real variables. Didn't really read the books, although I used them more for references. And then after that, I had real analysis and abstract algebra, which is like the beefier versions. And those classes were quite tough. Well, the algebra one wasn't that tough. The guy tried to make it as easy as possible. But the analysis was just, he didn't make it unnecessarily hard, but the subject itself is just hard. So I remember reading the book a lot more than the algebra book. Now, my last year in the master's program, was spring semester 2020, and that was when COVID happened and shut everything down. And when everything got shut down, the instructors would upload videos to the university website so that we could keep up with the lectures. But at that point, I realized I had developed a more mathematical maturity, meaning that I didn't really need lectures anymore. I could just take a book, read through it, and figure out how to do it by myself. And that was only after like several years of keeping with it. So the point of this story is that it may take a few years, and at the beginning you're going to be really bad at it. But if you do sit down and slowly go through the notes, you'll eventually get to the point where you'll be pretty independent when it comes to studying, and then it'll just come like, it'll be like riding a bicycle after that. That's not to say that you'll know how to do everything, but you'll be able to keep your head afloat, or above water, I should say. So what kind of advice can I give about how to study notes effectively or take notes effectively? I don't really have a tried and true method of it. You just kind of sit down, you write. And the more you do it, the more comfortable you become with it. I'm repeating myself a lot. So let me give you an example. I've been reading this Katznelson book in harmonic analysis. So one of the things I do to decide if a book is worth reading and putting in time is that I look at the table of contents and I'll see what kind of subjects they cover. So chapter 1's about Fourier series, chapter 2 is about convergence of Fourier series. And I just look at some of the things, see if I recognize words. Like for example, maximal function of Hardy and Littlewood. I've seen that before in real analysis. What else is here? Interpolation of norms and linear operators. I know what a linear operator is, so as long as I'm like recognizing the words, then I'm a little bit more comfortable with this book. Like it becomes more appealing to me. Like I want to actually sit down and read it. And also this book isn't too long. It's chapter 8, section 10, starts on page 250 roughly. So the book isn't too big. You can actually see it here. It's not that big. So these short books are kind of appealing to me as long as I have, the background of it that I can read. Because what you don't want to do is pick a book that's too above you. Because then you'll just like start and then you'll get stuck and then not finish. That's happened to me many times. So what I'll do is I'll look at this and I'll skim through it if I'm quite familiar with it. And because I'm taking a class in Fourier analysis right now, so my eyes immediately go to stuff like Lebesgue measure, 2-pi periodic, this integral that they've written here, translation invariance. And then I'll go to the next page and I'll just look at the main stuff. Trig polynomial, Fourier coefficient, wherever it is, how they write the Fourier series. Well, here's the coefficient, and here's the series. And then if it looks appealing to me, like at this point I've kind of made up my mind if this thing's worth reading. Because this is actually kind of a popular book, the Katznelson book. And I'll decide, all right, I'm going to try and read through this and take notes. And then you kind of have to decide to what level or degree you want to go into this book. Like how in detail do you want to do it? Like, do you want to just write down the theorems? Do you want to write down their proofs? Do you want to do problems? Like, how much do you want to do? And it kind of determines, hold on. Let's form a complete sentence here. You do what you want to do with it. Do you want to solve problems? Do you have time for this type of stuff? Or do you just want to casually read through the book if you're just interested in the results? As long as you understand what's going on, that's good. So for this book, because I am in the class, I decided that I just wanted to write down the theorems and not really bother with the proofs or the problems. Now, you pay for that if you don't do it, because most of the learning, I think, comes from writing down the proofs and, doing the problems. Because I felt like maybe that's the reason why I wasn't super successful the first time I took the qual, because I would just read through a book like this Zygmunt Whedon book, and not really worry about the proofs so much. I just wanted to be familiar with the topics. But I don't know, it's kind of hard to measure something like that. So for this book, I think what I'm going to do is just read through it, write down the theorems, try and understand what they're saying, and then it'll put me ahead in the class so that when he does something at the board, I'll go like, oh, I remember this topic from the Katznelson book. I want to see how he proves something. And the more you spend time with this, the faster you do become. Because there's a friend of mine in the graduate department. She, I think she's a little bit jealous of my speed. Like I pick up topics in real analysis pretty quickly, or at least relative to her. And I just tell her, it's like, it just takes time. You know, read through a bunch of books. They all kind of cover the same material and use a lot of the same tricks, and then once you see it, the speed comes later. But I wouldn't really call myself super speedy, but maybe to her I do. Okay, so when I actually sit down and do take notes, I try to write as little as possible. I think I've probably screwed this line up here, so please ignore that. But I denote the torus as r factor 2 pi z, the unit circle. And then I'll write all this stuff down. And I try to write as little as possible, but without losing a whole lot of details. I like to underline definitions of words so that they pop out. And I always make, if there's notation, like important notation, I will make sure that's written down as well. I don't know why I'm struggling to say that. Nth Fourier coefficient, the Fourier series, properties of Fourier coefficients. So again, I skipped through the proofs because I'm not really interested in writing them. Maybe someday in the future I'll go through it, but you should at least like read it in the book and try and go through each line, like, okay, how can I go from this line to this line, so on and so forth. But when you're just casually taking notes, I don't think it's too big a deal. And then it's also important to set small goals for yourself. So when I sit down and do something like this, I don't really try to, like if I can do a chapter a day, that'd be pretty good. But that'll usually take up maybe an hour or two, and then I'll get bored and want to do something else. But if the chapter is super long, like chapter 1 in the Katznelson book is like 40 pages, and the whole book is 250. Like this is just chapter 1. I finished chapter 1 today, so chapter 1 ended up being, so this was the last chapter, or last page. So you can see here how many sheets of paper it took. Yes, I know I'm not writing on the other side, but because these notes are special and I want to keep them clean, it's not that the paper's going to waste. Or at least that's the way I think of it. A lot of people suggest that I get an iPad and write it down that way, and if you want to do it that way, go right ahead. It's just, I guess I'm just old school, I don't know. I know I've tried taking notes with iPads before. It's just, it's hard for me to like flip through. I like being able to flip through something like this, pick up something, and it makes it easier for me to find stuff. And I can put it on a shelf and look at my work. Plus, if something happens to the iPad, you know, I guess you could upload it to the internet, or email it to yourself. Oh, I guess the real answer is I'm just lazy. I like writing on paper. So again, theorem, I'll underline it, write theorem here, hyphen, and then I'll try and simplify the statement as much as possible without losing too much information. And I do that for everything here. The definitions, you know, I'll box it and then I'll underline the thing that's important. Have it written here so that it pops out. And it makes reading through the notes much nicer. And again, if this was like 5 years ago, I would not be able to go through it this fast. But because in analysis, you know, once you've had real analysis 1 and 2, and then you take real analysis 1 and 2 again when you go to a different university, and then you take complex analysis 1 and 2, and then you sit on someone else's complex analysis class because you're weak in it, and then just so much analysis you've seen over the past 5-6 years, you start to learn how the game is played, and then that's when speed develops. So be patient with yourself, I guess, is the takeaway. So set small goals for yourself. If you can do a chapter a day, that'd be good. If not, do a couple sections. Don't pick up a book that's outside of your reading capabilities. You'll just get frustrated and stop. Don't be afraid to read other books too and look stuff up on the internet. Go to Wikipedia. If you see things from different angles, it all plays together, and then you're able to understand the material in one book better. Bessel's inequality. This is about all that orthogonal stuff I was talking about in the last video. Complete orthonormal system. So anyway, you can see the general layout of how I do each of these topics in the book. And if the book is good, you know, the less effort you have to organize this stuff, which is really nice. The Katznelson book turned out to be a pretty good choice for me. I'm still interested in the Tolstov book as well as that big red one at the bottom, but baby steps first. Anyway, so that's all I'm going to say about that. There are other notes I've done here. I've taken like this packet on ergodic theory and fractal geometry by Furstenberg. This book is very short. It's only like 60 pages, and it's for students to read. So here it is in case you're interested. And this book, because of how thin it was, and I'm not taking a course in it, I decided to do the proofs. So the proofs are in here somewhere. The fractal geometry stuff's interesting to me because my thesis involved fractals, as well as that one paper I co-wrote. I didn't write the whole thing. Where are the proofs? I know I put them in here. Oh, okay, so this lemma has a proof to it. So you can see how I structure the proof in case you were curious. There's not really problems in this packet. It's really just all lectures. Frostman's lemma. Here's a fun story about Frostman. I forget his first name, and you have to check me on these details because it's entirely possible that the story I'm about to tell had nothing to do with Frostman. I just got the names confused. But there's a guy at my university who teaches complex analysis at the graduate level, and he told us that his favorite mathematician was Frostman. And the reason that Frostman was his favorite is because apparently this guy had only written maybe 4 papers in his entire life, but his 4 papers were like groundbreaking, like they were legendary papers. So he just wrote 4 papers, became a legend, and then went out to the pub and started drinking, and that was his life. So it was like so his dream was to write like one great paper, and then you never have to work again. It's possible I got his name confused with someone else, but I think it's Frostman. I'll have to check that. Anyway, I thought that was funny. Anyway, so that's how I take notes. I hope it was useful. I filmed this once before and I didn't really like it, so I hope this one came out better. Let me know what you think. If you have any words of wisdom and how you take notes that can help someone, feel free to put it in the comments, and if it can help me, I'll read it too. Thank you.